In this session, we're going to explore parabolas. A parabola is a shape that is essentially defined by a dot and a line. The dot is called a focus, and the line is called a directrix. Now, what you probably already remember about parabolas is that there's also a dot called a vertex. That one's actually on the parabola. The other two just define the parabola. And a defining characteristic of parabolas is that any point on the parabola has a distance to the focus that's the same as the distance to the directrix. That would be a perpendicular distance right there. So this is true for any point on the parabola. That distance there would be the same as that distance there, which would be probably a little more clear if I had drawn this perfectly, but bear with me here. Since any point has the same distance from the focus as it does the directrix, it stands to reason that the vertex is the point that's halfway between those two. And the distance in green that we have here between the focus and the vertex is denoted P in most textbooks. Sometimes it's A, but we're going to use P. And this distance here from the vertex to the directrix is also going to be P. A couple of things I want to note. The focus is a point, and therefore it has coordinates, right? An X and a Y. The same is true for the vertex. It's a point, but the directrix is a line, and so it has an equation. If it's a horizontal directrix, then it would have an equation y equals some number. A parabola also has what's called an axis of symmetry, and that's what splits it down the middle. If a parabola has a vertex that's at the origin, then the equation of the parabola is simply y is equal to ax squared. This is for a parabola that would open up or down. By the way, it would open down if a is negative. And as far as this a is concerned, you remember this p, the distance from the vertex to the focus? Well, a is 1 over 4p. So that's just kind of how all these things relate to each other. Parabolas could also be oriented horizontally, in which case they would still have a focus, a vertex, and a directrix. But the directrix would be a vertical line, and so would have the equation x equals some number. The axis of symmetry would be a horizontal line. And if this parabola on its side had its vertex at the origin, then it would have the equation x is equal to a y squared. And it's still the case that the distance between the vertex and the focus would be labeled p, and a would still be 1 over 4p. We're going to explore parabolas with their vertex at the origin and parabolas with the vertex somewhere else. Sit tight. First, we're going to see a parabola with its vertex at the origin. We have analyze and graph y equals 1/8 x squared. And the first thing I want to do is I want to see about this p that we were talking about earlier. So a is 1/8, but a is 1 over 4p, and this is just a tool that we can use to figure out the characteristics of the parabola. But equating these two gives me that 1/8 is equal to 1 over 4p. This is really a proportion here, so we can cross multiply or solve it however you want to, but we have 4p is equal to 8, which gives me that p is equal to 2. Now let's go back here, and p is the distance between the focus and the vertex. It's also the distance between the vertex and the directrix. So I have my set of axes here. The vertex is at the origin, and if p is 2, then that means that the focus is 2 units up from the origin. Also, the directrix is 2 units down from the origin, and so has the equation y equals -2. Because of the orientation I'm looking at, I know that the axis of symmetry that we talked about before coincides with the y-axis. Now, let's go back and see what we can do knowing about P. So we said here a minute ago that P is how far the focus is from the vertex. But remember that we also said that the distance between any point on the parabola and the focus is going to be the same as the distance from that point to the directrix. So if we consider the line that goes through the focus and is parallel to the directrix there, the distance between the point on the parabola for that and the point on the directrix, the perpendicular distance, is going to be P and P. So this distance here is 2P. That's how far that point is from the directrix, which means that's how far that point is from the focus, because of the defining characteristic of the parabola. So this is a distance here of 2P, and the point on the other side of the focus that's on the parabola is also going to be 2P units away. And so going back to the drawing that we're making, where the focus is, I'm going to be 2P units this way to the right. That's 4 units because P is 2. And then 2P units to the left. And I see that the distance between these 2 points that I've just drawn in blue is 4P. Okay, so that P is kind of running around all over the place defining the parabola. Let me get rid of that label there. And now what I'm going to do is I'm going to try to draw a parabola that goes through these points here. And we can see that this parabola is kind of wide, which should agree with what we knew before regarding the coefficient on x squared. An important thing to note is that this parabola at the vertex here, let's make sure we draw it as a curve and not a sharp point, because parabolas are curvy. In any case here, let's label the focus, which is 0, 2. We've labeled the directrix, which is y equals -2. And sometimes we're asked to give the axis of symmetry, which in this case, vertical line being x equals, on the y-axis means x equals 0. This distance here between the 2 points that we found by the line that goes through the focus is called the focal diameter. Let me write that out. Focal diameter. And its length is 4P, and so in this case it's 8. We're essentially just going to use that to help us to graph parabolas, which we've done here. The last thing that we would have to write down to analyze the parabola would be make sure we label the vertex. And the vertex here is at the origin, 0, 0. So the focus, the vertex, and the directrix labeled. The graph drawn as best we can. And at the focus, the width of the parabola is 4P. See what you can do to analyze and graph x equals -1/2 y squared, noting that since y is what's squared, this will be a horizontally oriented parabola. Okay, so a is equal to -1/2, and we know that a is 1/4P, and so -1/2 is equal to 1/4P, which means that -4P is equal to 2, or P is equal to -1/2. What does it mean that it's negative? Well, that it opens in the negative direction. Since this is horizontally oriented, that means it's going to open to the left. So I have my axes here, labeled x and y. Vertex is at the origin. For record keeping, I'll write down that the vertex is 0, 0. Since p is negative 1/2, we're opening to the left. We already mentioned that. And that means that the focus is 1/2 of a unit from the vertex. Instead of trying to cut up my squares in small little pieces, I'm going to make the scale of my axes such that 2 squares represents 1 unit. That way I can say that the focus is 1/2 of a unit to the left of the vertex, and it'll still be where the squares meet. And the directrix is going to be vertically oriented, and as such is going to be x equals, and remember that the distance from the vertex to the directrix is the same, p. So x equals 1/2 is the equation of the directrix. The axis of symmetry is oriented horizontally and would have an equation y is equal to 0. And then let's deal with the focal diameter. We may remember that the focal diameter is 4p, which I already have as 2 right there. So I'm going to go 1 unit up and 1 unit down for a total of 2. That's what 4p is. Well, technically negative 4p is 2, but we're talking about a distance, so that negative doesn't apply. We're just after the magnitude. So that distance is 2. And that's going to help me to draw my parabola here. I make it curvy, and I hit those 2 points that we wrote down. For, again, bookkeeping here, the focus is at negative 1/2, 0. So wrapping up, p is negative 1/2. The negative tells us it opens in the negative direction, and the 1/2 is the distance between the vertex and the focus. It's also the distance between the vertex and the directrix. That distance being 1/2 means that the directrix has an equation, x equals 1/2, vertically oriented directrix. And again, that being negative 1/2 gives me that the focus is at the point 1/2, 0. The vertex is at the origin. We're going to see in the next example one where the vertex isn't. And then finally, the focal diameter, the width of the parabola where the focus is equal to the magnitude of 4p, which in this case is 2. For our next example, we are going to analyze and graph y equals 1/8 times x minus 3, the quantity squared, plus 2. The first thing I want to point out is that this equation is in the form y equals a times the quantity of x minus h squared plus k. And as I'm sure you remember, the vertex of such a parabola is at hk. So for this particular parabola, the vertex is at 3, 2. Everything else that we have just done still applies. So as in the first example, a being 1/8 and a being 1/4p tells us that p is equal to 2. I have some axes here, and I'll label 3 and 2. That's the dot where the vertex is going to be. Because this equation has the x as the part that's squared, this is going to be a vertically oriented parabola, meaning it'll open up or down. And because a is positive, it's going to open up. Since p is 2, I know that the focus is 2 units up from the vertex, and the directrix is 2 units down. And so the directrix has the equation y equals 0, and the focal diameter, let me write this, focal diameter is 4p, and so in this case 8. Remember, the focal diameter is the width of the parabola at the focus, and so from the focus I'm going to go 4 units to the left, 4 units to the right, in other words split that 8, and then draw a parabola that matches those characteristics. We can start to label our stuff here on the graph. The vertex, as we said, is 3, 2. the focus has an x-coordinate of 3, and for the y-coordinate, it's 2 units higher than the vertex was, and so 3, 4. Focus, vertex, directrix. If we care, the axis of symmetry has an equation of x is equal to, and we can just pull the x values from the other guys, x is 3, and as we already mentioned, the focal diameter, which is the width of the parabola at the focus, is 8. Next, we're going to analyze and graph x equals negative 1/2 y squared minus 4y minus 10. Notice that in this case the y is squared. That means it's going to open left or right. And since the a is negative, it's going to open in the negative direction. So in this case, that means to the left. In the last example, we had the equation in the form y equals a times the quantity of x minus h squared plus k. This time, I want the equation in a similar form, but since x and y are changing roles, h and k will change places as well. We're going to want to get this, let's make our goal, get this equation to be in the form x is equal to a times the quantity of y minus k squared plus h. I want to point out that x goes with h, and it'll always be the case that k goes with y. The vertex of the parabolas is always going to be hk. In other words, the number that's with the y variable is the y coordinate of the vertex. The number that's with the x variable is the x coordinate of the vertex. Knowing that I want to get the equation in this form, x equals a times y minus k, the quantity squared, plus h, I know I need to complete the square. So, I'll rewrite the equation here. X equals negative 1/2 y squared minus 4y minus 10. And as you may recall, when we complete the square, first we factor out the leading coefficient from just the terms that have the variable. So in this case, that means factoring out the negative 1/2. That leaves us inside the parentheses with y squared plus 8y. Remember, factoring looks a lot like division. So what we've essentially done is we've taken that negative 4 and divided it by negative 1/2 to give us that positive 8. I'm going to leave a gap but close the parentheses, and then I'll write negative 10 because, as you may remember, when we factor out from the terms that have the variable, the term that doesn't have the variable, the constant, we leave it alone. Now inside the parentheses, I'm going to add the correct number that makes it a perfect square. So we take 8, cut it in half, it gives me 4, square that, and so I add 16. But then what did we really add? We have to remember that the coefficient would multiply by what we just added, and so that negative 1/2 times 16 would be negative 8. So we really added negative 8. To offset adding negative 8, I'm going to add a positive 8, because negative 8 and positive 8 add up to 0. That keeps everything all nice and clean. Finally, when I factor the perfect square trinomial, I have x equals negative 1/2 times the quantity of y plus 4 squared minus 2. Knowing that the number that goes with the y variable is k, means that the other number is h. Keeping in mind that we changed the sign of a number in parentheses and we don't for the numbers that aren't, the vertex is going to be negative 2, negative 4. I know it's weird to kind of try to switch it up like that, but just remember the number with y is the y coordinate, and anything inside parentheses leads to a sign change. Okay, we can also write down that a is negative 1/2. Remember that a is 1 over 4p, and so we've got that p is negative 1/2 as in the second example. Here I have my x and y axes, and I'll label -2 and -4. And that's the dot where I'm going to put the vertex. And this time I'll just deal with the half units. Remember that the negative tells us that it's going to open in the negative direction, which in this case means to the left. And the value of 1/2 indicates that my focus should be 1/2 of a unit from the vertex. So should my directrix be. So this directrix is a vertical line, and so has an equation of x equals. And to figure out the value it is, it's -2 plus 1/2 to the right of -2. So this is going to be x equals -3/2. You could call it -1.5 or -1.5, I don't really care. For bookkeeping, let's write down that the vertex has coordinates -2 and -4. And then for the focus, from -2, we're 1/2 a unit to the left. That would be -2.5 if you want. I'm going to call that -5/2. And then the y value is -4. At the focus, the width of the parabola is 4p. And remember, when we consider that, we don't care that it's negative. We really just care about the magnitude. In this case, that's 2. And so at the focus, we're going to go 1 unit up and 1 unit down, giving us a focal diameter of 2. Let me get that out of the way now. Starting at the vertex, I'm going to make sure that I go through the point that defined the focal diameter. And what all do we have? We've got the vertex at -2, 4. We had to switch the places of the numbers because the number with y goes with y. The focus is p units in magnitude away from the vertex. In this case, that means to the left. And so that gave us a value of -5/2 for the x-coordinate, -4 for the y-coordinate. So focus is at -5/2, -4. Directrix is p units on the other side of the focus, and so had the equation x equals -3/2. The focal diameter, the width of the parabola at the focus, in magnitude is 4p, and so has a width of 2 at that point. And finally, if we care, the axis of symmetry, which is the line perpendicular to the directrix that goes through the vertex and the focus, in this case has an equation of y equals, and we use the y coordinates of the stuff we've already written down. Y equals -4. One more example, and then we'll wrap up with a summary of all the equations we're looking at here for parabolas. The example is to find the equation of a parabola with a focus of 3/9 and a directrix of y equals 7/8. And I want to draw basically a quick and dirty sketch so I can see what I'm looking at. And if the directrix is y equals 7/8, well, let me label some axes here. 3 there, 1 there. Y equals 7/8 is just lower than 1. And if the directrix is horizontally oriented, then I know the parabola will open up or down. The focus is at 3/9, and it's probably easier to think of 9/8 in this case as 1 and 1/8. That's just bigger than 1 with an x-coordinate of 3. And I know that the vertex is halfway between the focus and the directrix. So if the focus has a y-coordinate of 1 and 1/8, and the directrix is y equals 7/8, then halfway between 9/8 and that 7/8 is going to be 1. I know that the vertex has coordinates 3, 1. Recalling the equations we saw earlier for parabolas, one of them was y equals a times the quantity of x minus h squared plus k. I'm choosing this one because clearly the vertex isn't at the origin, so we have to have this h and k. And because the directrix is horizontally oriented, meaning that the parabola is going to open up or down, in this case up, I know that we're looking at x as the thing that's in the squared quantity. Now that we have our vertex, I know that it's y equals a times x minus 3 the quantity squared plus 1. Now it's left to us to find a. A is equal to 1 over 4p, and p is the distance between the focus and the vertex. In this case, p is 1/8. So, a is going to be 1 over 4 times 1/8. That means that a is equal to 1 over 1/2. The reciprocal of 1/2 is, of course, 2. And so finally we can say that the equation is y equals 2 times the quantity of x minus 3 squared plus 1. It's time to wrap all this up. The equations that we saw are y equals a x squared. That's for a vertically oriented parabola whose vertex is at the origin. And then we saw x is equal to a y squared, and that would be for a horizontally oriented parabola whose vertex is also at the origin. In both of these cases, if a turned out to be negative, then the parabola would open in the negative direction. If the vertex is at somewhere other than the origin, then we had y equals a times the quantity of x minus h squared plus k. Since x is in the squared portion for this equation, this is a vertically oriented parabola, meaning opening up or down, with its vertex at hk. The equation of a horizontally oriented parabola with vertex not at the origin is x equals a times the quantity of y minus k squared plus h. That would again open left or right. If a is negative, opening to the left. If a is positive, opening to the right. The vertex is still at hk, and notice that k is with y, h is the other guy. For the vertically oriented parabola, h is with x, k is the other guy. Finally, in the case of any parabola, there's a focus, a vertex, and a directrix. This is vertically oriented. If it was horizontally oriented, we'd have the vertex, the focus, and the directrix. And now we can throw in a picture of the axis of symmetry. I don't know how much we need that, but it's there. And the distance between the focus and the vertex is what we call p. It's also the distance between the vertex and the directrix. We use the same p in the case of a vertically or horizontally oriented parabola. And in all of these cases, a is equal to 1 over 4p. Finally, 4p is the width of the parabola at the focus.